Hey everybody, this is Larry. This is me doing day 29 of the October Lead Code Daily Challenge live. So hit the like button, hit the subscribe button, join me on Discord, let me know what you think. And as I said, these are live, so it's a little bit slow, just fast forward whatever you need to do. Today I may be rushing a little bit because I do need to get out of here, but we'll see how it goes. Okay, so today's problem is whiting oranges, 994, medium problem. Okay, so you have a grid, you have, okay, any fresh diamonds 4 directionally adjacent to a one orange. Return the number. Okay. Well, this one's a little bit weird in that. Well, the first thing I wanted to see was just the constraints, right? Because I think conceptually you would do a breadth first search, um, just like a distance thing from. So basically, maybe it's not breadth first. I mean, you would implement it that way with a queue, but basically you're doing multi-source shortest path from a place, and that would be the multi-source shortest path from all the rotten oranges to all the fresh oranges, right? And then you just get the max of all the distances from all the oranges and so forth. I think that should be good, but so that would be the linear way to do it. You look at every cell once, and that should be good. In this case, though, m times n is 10, so it's a little bit easier. So you can do something more brute force by literally just keeping track of all the wine oranges, and then just do the what's it called, the Manhattan distance from the closest rotten orange, and that should be good. And of course, that's going to be n squared, or it's going to be quadratic, which is m times n square, or m squared times n squared. Well, I like to say r squared times c squared, right? And that still would be fast enough because that's just 100 square. I'm going to do it that way because I'm in a rush, but I would recommend you doing in the linear time way, which is also not that much harder, to be honest. Okay, maybe I should do it that way. Let's see what time I have. But basically, what you're gonna do is, yeah, I mean, I think that should be okay. So let's get started then. But basically, this is just general shortest path thing. We have a queue, we have a collections.deck, because that's the implementation in Python. And then let's keep track of R is equal to length of grid, cell is equal to length of grid of 0. We have at least 1, so we should be able to check. And then here for X is in R, for Y is in range. If grid of XY is equal to 2 for wine oranges, then we let's keep track of distance. Yeah, let's keep track of distance is equal to let's just say infinity times c for wait, infinity. I just set it to some big int. I don't like using I don't like using float dot whatever float parsing because it is a different primitive, I suppose. But yeah, but distance of x of y is equal to 0, and then we append xy, right? Okay, and then this is standard BFS type thing of first in, first out. So xy is equal to q dot pop left, and then now we look at all the adjacent neighbors, so we have to look at the directions. Wrote this in a weird way, but okay. For dx, dy, and directions, nx and y, I use the same notation though. You don't have to. What this is just saying is that the next x and the next y, and then we just make sure that it is in bound. R and O and distance of nx and y is not, if it is infinity, then we want to relax it by going to the next thing. So we set this as equal to distance of xy plus 1, and then we push on the queue. And I think we should be mostly good. We can print it out, the distance. Oops, what did I click on? But really, all we have to do is just take a max of, so t is equal to 0. Yeah, for x in range of R, for y in range of C. Though I know you can write this in actually much terser way, but oops. Return t, right? I think this should be good. That's one of the example cases. Oh, this is wrong. So we only cared the longest distance if it is if the grid is equals to 1, right? Because we don't care about empty, the distance to the empty cells. I thought about this when I was like, how come we don't use this? But okay, seems like I'm still wrong. But why do I output 4 for the second one? Oh, maybe I misread something. Hang on. Oh, so it's not the distance because okay, so I'm glad that I didn't do it the Manhattan distance way, because only if it's a fresh orange. So okay, so I mean, but that's not that bad. We just have to add it here, and because you only pass from a rotten orange here, we can do this and it'll be fine. We don't have to change the grid or anything like that. Okay, that is just awkward then. Oh, I meant NX and Y. Maybe I'm rushing a little bit because I do have to go pretty quickly. Okay, so that looks good. I didn't realize that there's a -1 because this is impossible, but that's straightforward, which is that if t is equal to infinity, then we return -1, which is, I think that should be good. But that means that there's an orange that is not rodable, and that therefore the distance is infinity. Cool. Is this all I have? I think so. I mean, unless I missed a case somewhere. Yeah. Oh, I think this would be a case that I would be looking at, which is that there are no fresh oranges to begin with. And I guess this is the other case. Okay, so let's give it a submit then. And hopefully I don't have any. Oh no! Did I have a typo somewhere? Huh. I guess so. Oh yeah, I do have a typo in the directions. So I did worse than last time. I thought this. Oh wait. Yeah, I wrote this really funkily, and I thought I did wrote it funkily, but I didn't double check. But basically, I just didn't go on the negative. I mean, that was just wrong, right? So, yikes! Whoops. Like I said, maybe I'm rushing a little bit too much today, but at least this should be right. Let me double check real quick. Yep. Okay. Maybe there's another silly mistake, but this part should be okay. Okay, 577. Rushing a little bit. My bad, friends. But it is fast. This is just regular breadth first search. I think that's all I have. I mean, this is linear because we look at each cell once. This is linear space as well because of this distance thing. Do I need it? Yeah, I think we need a distance thing because otherwise, you need to keep track of the states you've seen anyway. I mean, there are some hacks you can do with extra space, but let's ignore that for now. But yeah, so linear time, linear space, and linear in this case is R times C, which is the size of the input, right? So yeah, that's all I have for this one. Let me know what you think about everything, the video quality, the code, any comments. I'll see you out later. Stay good, stay healthy, to good mental health. And I'll see you later. Bye bye. And also happy Friday.